One, start.
Hello, I am Atul Gupta, and today we are doing the experiment with piezoelectric sensor. We will be finding out the resonant frequency of that. So first of all, here is the input signal. The input signal is coming from a signal generator. We have currently set it to the amplitude of 10 volts peak to peak, and the frequency is 200 hertz. The input signal is going into this piezoelectric sensor, and across that is connected an oscilloscope. So this oscilloscope is taking the input signal, is displaying the input signal in channel 1, which is shown in yellow, and we are also getting the output signal from the piezoelectric sensor into the oscilloscope in channel 2, which is the blue one. Current, we can also see the peak to peak voltages of channel 1, channel 2, and the frequencies and the phase difference between the two.
Hello, I am Ayush Allad, and in this experiment we will be varying the frequency using the signal generator, and we will observe the change in the output voltage. So on increasing the frequency in small intervals, we can see that the output voltage is increasing, and at one point it peaks and then starts diminishing. This frequency is called the resonance frequency, and maximum output voltage is seen at this frequency, that is found to be 250 Hz.
These are the readings that we have obtained from the experiment. We have gone from frequency 100 to 20 kilohertz. The input and output voltages are in millivolts. This column is for the magnitude response, which is V output upon V input, and this column is for the decibel gain. These are the graphs that we have obtained. This is the magnitude response graph, and this is the phase response.
From these graphs, from the data that we got, we can conclude that the resonant frequencies of the piezoelectric sensor is 250 Hz and 1715 Hz. Using these resonant frequencies, we can calculate the quality factor.
The quality factor comes out to be 6.25 for the 250 Hz frequency and 9.21 for the other peak. Hello, I am Atul Gupta, and today we are doing class 2 of the assignment. We can see here, this is the circuit for the assignment, for the task. We are getting the signal from a signal generator. We have given a 5 volt peak to peak amplitude and a 5 volt offset. Currently the frequency is set to 200 Hz. We are getting this signal. Before this half of the circuit, we have the left side. We are getting the signal here. It is going into the LED, which is why it is lighting up. And then we have connected a 470 ohm resistor instead of the 330 given in the circuit diagram, because we only had a 470 ohm resistor. So we have connected an oscilloscope across the resistor, which we can see in channel 1 on the oscilloscope. The right side of the circuit is the right side displayed here. We are getting this 5 volt DC supply from the breadboard module in this line. It is going into the photodiode in reverse bias, and then it is going into a 10 kilo ohm resistor. We have connected another oscilloscope channel across this 10 kilo ohm resistor, which we can see in the blue color on the oscilloscope. So this is the circuit diagram for the task.
Hello, I am Ayush Allad, and in this task we will be varying the frequency using the signal generator, and we will vary it on intervals of 10 Hz and see the changes that will occur in the output voltage as well as the phase difference. The input voltage will remain constant throughout, as we are supplying the input voltage at a constant of 5 volt peak to peak. In this task, we will be seeing the trend that is followed by the weak peak to peak of the output voltage, and also the phase difference between the two channels.
These are the readings that we have obtained for task 2. Again, the input and output voltages are in millivolts. This is the gain, and this is the decibel gain. These are the graphs that we have plotted using these readings. The gain and decibel gain are shown in these graphs, and the phase response is shown in this graph.
From the magnitude response graph, we can see that the gain is approaching 0. This is due to the photodiode saturation on higher magnitudes of frequency. We can see that the the bandwidth of the photodiode is crossed, and the photodiode is saturated. Also, we can infer from the graph that the 3 dB cutoff frequency is at 4.5 megahertz.